All right, today we're going to talk about dividing using the area model and the standard algorithm. We've talked about using both those models or strategies for multiplication, and today we're going to explore some division. I'll bring this problem out. 49,789 divided by 81. I'm going to write this problem using the standard algorithm over here to the right. 81, the divisor on the outside of the house, and the dividend 49,789 on the inside. I'm also going to write that divisor of 81 over here near my rectangular array for my area model. Above this rectangular array, we're going to have our answer or our quotient pop up here, just like our answer or our quotient pops up at the top of our division house. Make that a little bit bolder. All right. So we're going to start off with 49,789, and we're passing that out to 81 people. We try to contextualize this by saying it's $49,789 that's being passed out to 81 people. Before we begin, we've got to figure out how many digits our answer will have. So to do that, we look at our standard algorithm over here, and we ask, does 81 go into 4? No. Does 81 go into 49? No. Does 81 go into 400 something? Yes, it does. Okay, so we're going to think about this 81 as being 80. Think. It's 80 plus 1. Okay, so we're thinking about this 81, changing in our head to make it a little bit simpler. Because when we get to our multiplication step in our standard algorithm, we can use the distributive property and pass the number out to the 80 and then pass the number out to the 1. Okay? We also need one little more thing down here for our area model, a little subtraction section. Call it our subtraction bubble over here. We're going to have a running subtraction record of our differences to figure out the end quotient. So let's go ahead and start by thinking about the front end of this number. 81, let's just look at the 8 in the 81, and let's just look at the 49 and the 49,789. Instead of looking at this whole number and being intimidated by it, let's just look at the 8 and the 49, because everybody knows how many times 8 goes into 49 without going over. It goes in 6 times. Change that to 6 times. All right. Now we're going to multiply to prove that. But before we do, I got to set up my area model as well. Typically, wouldn't be doing both of these at the same time, but I want people to see how these two strategies are very similar. We're going to have a 3-digit number for our answer, 600 something something. So over here, I'm going to break this into 3 sections as well. We figured out our first digit is a 6, and the value is hundreds, so it's going to be 600 in our answer over here. Multiplying this out, 6 times 80 is 480, and 6 times 1 is 6. Put those two products together, we get 486. What's nice about this, if I did the multiplication over here in the standard algorithm, of course the same product exists over here in our area model. So I'm going to write down 486. But in our area model, we have these zeros that we have to drop down and include. So how much have we given away of our entire 49,789 already? We've given a significant amount away already. In my subtraction bubble, I'll write out what we started with, 49,789, and I'll take away what we just passed out, 48,600. Okay, well, I'll do our subtraction here, and we have 1,000 189 left to pass out. Same subtraction happens up in our standard algorithm. And then we'll bring down this next number, and you'll see that our front ends are the same. We have a 1, and an 8, a 1, and an 8. Okay? What's nice about the standard algorithm is that it kind of shortens it up, it abbreviates it. But that 9 is right here, just like that 9 is right here. For our purposes, though, we're going to leave that 89, and let's go ahead and look at the front end again. 8 goes into 11. Pretty obvious how many times 81 goes into 118 in this problem. It's only going to go in one time. So I'm going to multiply to prove that, 81, and then I'm going to subtract 8 minus 1, 11 minus 8, 37, and then I can bring down my next number, my 9. Same thing's going to happen over here. I put a 1 up in the tens. That means that it's worth 110. And then I can multiply that out. It's going to be 810 has been passed out of my 1189. 9 minus nothing, 8 minus 1, and 11 minus 8. We see we have our 379 and our 379. We'll do one more division step. 8 goes into 37. Again, we're just looking at that front end. We said 8 goes into 37 now. How many times without going over? It goes in 4 times, because 4 times 80 is 320, and 4 times 1 is 4. So it's going to be a 324. Let's go ahead and subtract that out. Be a 5 and a 5. Looks like we have a remainder of 55. Again, that 4 ones also goes over here in our area model, and we multiply to prove it, 324. So right now we've finished that problem up. We see that there's 55 left over, and we can also show that down here in our subtraction bubble by doing the subtraction down here for our area model as well. 55 left over. We're going to go ahead and put our partial quotient together here. 614 with 55 left over out of our 81. Our divisor becomes our denominator, and our remainder becomes our numerator.